This is where we stopped last week. When we talked about expanding, there were two rules that we tried to follow. First rule is when we expand, we will typically... Okay, so when we expand, sorry for that interruption, we're going to expand product and quotient rules first. That's what we attack first, typically. The second one will be expanding power rule. So to recap, we had a product we separated with a plus sign, and then we had a power that we moved out in front. I want to show you the difference between our old example and what this one looks like. Because typically we do the product rule, the quotient rule, and the last thing we do is a power. But that's if we don't have parentheses. Because this entire thing's being raised to a power, I actually would have to take care of that power first. This is an example where it would go against my typical rules, where you'd have bringing the power out in front. Log base 5 of 2x. And then wait a second, this argument has a product between a 2 and an x that I'd have to separate. So this would be 6 times log base 5 of 2 plus log base 5 of x. Notice how, wait a second, because this coefficient, because this power went to both pieces, it was in the group, notice how I have to keep that group in parentheses. So be aware that if you have a grouping symbol, you're going to have to keep a grouping symbol, or make sure that that 6 gets distributed. This is an acceptable answer, but there's also, you could take it a step further and distribute 6 log base 5 of 2 plus 6 log base 5 of x. So be aware. If you have a grouping symbol, you're going to have to maybe not pay, you can't go exactly by my rules. You've got to make sure if I have a grouping symbol, I undo what's holding that grouping symbol together. We're going to practice condensing. So we're going to practice going the opposite way using our property chart. We're going to start with something elongated and try to get down to a single logarithm. You'll see what I mean when I mean single logarithm. Typical steps are to undo the power rule first. This is if I have no grouping symbols. We're going to undo the power rule first. The second step will be to undo product or quotient. Moving this 2 to be a power. So my first step, log base 6 isn't changed, but then I add common log of 2 squared minus log 3. So that coefficient now becomes a power. That's extremely important. As I look through my new logarithms, I no longer have coefficients. I'm now going to have to undo product and quotient rules. I've just got to figure out how am I going to undo product and quotient rules. So I'm going to say that again. Instead of this plus sign, I'm going to multiply these arguments. This is going to look like log of 6 times 2 squared. I condense their logarithm. And then I have minus log 3. So this minus sign means I'm going to use division somewhere. And I'm going to take the first and then divide it by 3. So it's going to look like common log of 6 times 2 squared, all divided by 3. Last step is to clean it up. Like, is there anything I can get together? And notice how I've got all numbers in here. So I'm going to take 6 times 2 squared divided by 3. So 6 times 4 got us 24 divided by 3. This is common log 8. I don't need parentheses in my answer, but common log 8. We just went from something that was elongated or expanded to a condensed logarithm. How do you know you're done with a condense? Is when you have a single logarithm and no coefficient. There can't be a coefficient out here because a coefficient means, wait a second, if you have a coefficient, that means you didn't do a power. You should have done the power rule. Next example. So we're going to condense 2 log base 3 is 7 minus 5 log base 3 of x. I notice there's no grouping symbol, so I'm going to use the typical steps as a power. So log base 3 of 7 squared, and then the 5 goes up as a power. And then, yeah, I see the minus sign, so I'm going to use the quotient rule. Going to use the quotient rule after this. This is the second step. I've done everything with the coefficient. And I'm going to have log base 3 of 7 squared divided by x to the 5th. Last step is to clean it up. This is my final answer. So after we condense it to a single log, always check to see is there something I can actually compute. So on to the next problem. We're going to undo the power rule and then undo quotient or product if needed. So because every single logarithm is being added, we're taking 2 to the 7th times x to the 5th times y cubed. And the last step will be to clean it up. Can I clean something up inside those parentheses? So when we clean it up, just compute whatever we have. There's something else we got to discuss, and it's about change of base. It's called a change of base formula. Some of our calculators actually cannot compute something that is not base 10, because that's the common log, or something that is not base E, because that's our natural log button. So in the next piece, we're going to talk about how can we do logarithms of some other base. So if you have any base other than 10 or E, it can be rewritten in terms of using the common log or natural logarithms, using a change of base formula. If you let U, B, and C be positive numbers, and there's a typo on my PowerPoint where B is not 1 and C is not 1, then we can take log of any base with any argument and make it a log with the same base of the argument divided by log base B of the old base. Here's why we really need it, is so that way we can use our common log button on our calculator or our natural log button on our calculator. We're going to evaluate these using the change of base formula. So if we have log base 3 of 7, notice what is in the position of the C and the U. We want to be able to put this in our calculator by using the common log button. So I want common log of something divided by common log of something. We've got to figure out those somethings. Since U was in the argument spot, common log of U, so I'm looking at the 7. Okay, then obviously divide it by common log of 3. Since 3 is in the C position, I match it. Here's how we put it in our calculator. So this is how we will put it in a blue calculator. If you have a green calculator, you know who you are. You've got to do the reverse, where you have to do 7 common log divided by 3 common log equals. So you should be getting 1.771 when you plug this in. We're also going to test, does it change the answer if we put in ln, if we use the natural log button? So, go through the same process, use the natural log button. Answers do match. We're going to do log base 4 of 8 next. Do that on your own. See if you can match it up. Log base 4 of 8. So we should be getting 1.5. I should also use this. Wait a second, 1.5 exact? Okay, let's check this real fast. Log base 4 of 8. If we said, okay, that equals what? We did this strategy last week, so let's not forget about it. But to rewrite, if I rewrote that in the other form, a way to check our answer is if we took 4 to the what power gets us 8. See if 1.5 fits this. 4 to 1.5. 4 to the 1.5 power, does it spit out 8? This only works if you have a terminating decimal. In the previous example, 1.771, we had to cut it off. We had to round it. So if we tried to check it, we'd have to make sure, okay, well, since I rounded here, I would have to round my answer to see if it actually did spit out to be 7.